Hello everyone. This lecture is about the periodontium. Periodontium, what does that mean? It means everything that is next to the tooth, or more specifically, how is each individual tooth attached to the bone? The periodontium. Which structures do we find next to the teeth, and how are the teeth attached to the bone? Our patients see the gingiva, which should hopefully always be healthy. And there is a separate specialist discipline which is called periodontology, and in this lecture we talk about the structural biology behind it. The topics, or if you like, the learning objectives, are the question of the origin and development of periodontal structures, the parts of the periodontal tissue, and its structural composition. The term biological widths has a special significance for working on patients, which we will of course go into more detail in this lecture, and by the end of this lecture you should of course be well prepared to understand the clinical relationships between the structure of the periodontium and its possible damage when you read the relevant specialist literature. There is, of course, a great deal of recommended literature on what you will see and hear in this lecture. But ultimately, all the content that I address in this lecture can of course be found in pictures and words in my textbook, Oral Structure and Biology, and in the atlas The Face, which is why I always include the page numbers in the top left-hand corner. So we see that the teeth project into the oral cavity, at least with a crown. The root of the teeth is embedded in the bone. And how are they attached there? And of course, just as importantly, how is the emergence passage sealed? The mouth is the opening to the environment, and you probably have an idea of how clean or how not clean it can be in the mouth. And at the very least, the inside of the body, including the periodontal area, should be clean, even sterile. And as you can imagine, we do not want infections in the periodontal tissue, and they should of course be avoided. And this diagram shows how it can be structurally prevented. On the left at A is the overview, and on the right at B, we first see the dentin in dark gray, at D, the enamel E in light gray, and at C, there is a thin layer of dental cementum on the dentine on the root of the tooth. From here, and now let's look at the diagram starting from the bottom right, the cemento-alveolar fibers run from the cement to the bone. And these are mainly collagen-containing fibers that have grown into the thin layer of cementum and have also grown into the bone on the opposite side. And the alveolar bone is shown in dark gray, and the structure in the far right is in pink. This is the alveolar mucosa. And there is a very detailed extra lecture on the oral mucosa where the details will be added. And if you look at the diagram above, we can see the gums, their internal structure, and of course they also have many individual anatomical parts. The dentogingival fibers run inside, which means from the tooth to the gingiva. They are highly fanned out and run under the epithelium from the inside. And if they are healthy, they can pull the gingiva really tightly against the neck of the tooth. And this alone contributes to a large extent to the mechanical seal. And that is why the gingiva is so pale pink. It is well supplied with blood, but the tissue should be nicely tight. And in contrast, an inflamed gingiva would be dark red and the tissue softer, even flabby. It would bleed simply by touching it. and the blood vessels are thicker, more permeable, and the fibers are then even partially broken down by the enzymes, which are more present during inflammation. So there would not be much of the beautiful, important tonicity of the fibrous parts left. It is interesting what you can talk about in a simple diagram. Details and even more pictures are coming soon. Let us take a schematic look at the anatomical details of the gingiva. On the outside, we have the attached gingiva, which is the area that looks pale pink when you look in the mirror. And then there is the gingival margin at the very top, and this outermost area of the gingiva is more freely movable, which is why it is called the free gingiva. And the gingiva is attached to the tooth directly, to the clean enamel surface, and this area is called the junctional epithelium. For orientation, the outer part of the free gingiva is called gingival sulcus epithelium, and the area facing the tooth is called oral sulcus epithelium. Now this is not a mistake, I have read it up everywhere. The part facing the tooth is called the oral sulcus epithelium. I really don't think that makes much sense here. This area faces the enamel and has not so much to do with the mouth. But for these names, it's not my fault. In contrast, the highest point of the gingiva, which is the transition from the gingival sulcus epithelium to the so-called oral sulcus epithelium, is called the gingival margin. And yes, that's easier to remember, isn't it? Okay, and there is one more feature to be mentioned. The gingival groove. That is a very delicate little furrow at the border between the free gingiva and the attached gingiva. What we have just looked at so schematically can be seen more vividly here in the beautiful anatomical drawings by Carl Weska from our atlas. Let us come closer, then we see what is marked here in the white box, even a little bit larger. Here we have the enamel on the neck of the tooth, the gingiva. You can also see how it is well supplied with blood vessels and also with nerves. Then here the dentine with one of many of the 1,000 connecting canals between the pulp and the periodontal space. And then drawn here in yellow, a little thicker than it actually is, the dental cementum. And here the alveolar bone. And yes, and in between, that's the periodontal space with the supporting fibers, also known as desmodontal fibers. And in the spaces between the fiber mesh, there are also the many blood vessels and nerves and everything. And now that we have seen the important structures first in the diagram and then in the anatomical atlas, we can look at the periodontal structures in the real histological section. So here we have a vertical section in which I have also labeled all the important structures properly. Again, we can see the epithelium of the gingiva at the top of the image, colored deep purple, and below the connective tissue with its many fibers, which is more pink. And if you look closely, you can already recognize them, and the white area is where the enamel used to be in this decalcified histological section. It is, of course, no longer there. And on the right, you can see the dentine of the tooth and the alveolar process bone at its edge. At the limbus, you can see beautiful Haversian systems with blood vessels in them, and you can also see the bone marrow spaces very much enriched with fat, which suggests that this preparation comes from an older individual. And if we now want to see the supporting fibers in more detail, then we have to look at the specimen again at a higher magnification. And that is what is framed here in the white box again, and we can see the enlarged situation here on the right. The fibers now run obliquely from the top left to the bottom right in the periodontal space. You can also see many cells, especially fibroblasts here. And of course, the periodontal space is also filled with all kinds of other cells, like for example macrophages and cells of the immune system. And in addition, this periodontal space is also filled with fluid, which is also connected to the bone marrow spaces. So we have seen that the teeth are suspended in their bony cavity by fibers. These fibers have a certain elasticity, which is why you can even feel a tooth wiggling a bit if you grab it very firmly. The periodontal space has a diameter of around 250 micrometers, which is a quarter of a millimeter. You can see this a little bit if you let your tooth rock back and forth and if you look very closely. In periodontology, much greater degrees of tooth mobility are distinguished on the patient. So if you can wiggle a tooth back and forth with a mirror handle and you can see it quite clearly, that is, of course, a very pathological condition. And you can also do a little experiment on yourself. Bite together slowly. And can you feel your teeth now? And slowly increase the pressure. And now you will feel a certain elasticity. Now increase the pressure again and let the force take effect. And now you can feel that your teeth are sinking in, can't you see? And with a simple experiment, you have now felt for yourself that your teeth are elastically suspended in the bone with fibers that can be stretched a little bit, and that there is a gap between the tooth and the bone, which is filled with a fluid that can be also displaced a little bit. But where does it go? We have seen the large many bone marrow cavities in the bone, which are also connected to the periodontal space, and there it goes. The teeth are therefore both elastically suspended in retaining fibers and also hydraulically cushioned. I can also confirm this from our own experience. My retention splints. I assume that many of you also have such retention splints. You get them after an orthodontic treatment to secure the treatment result for life. So when I put my retention splints in, I can feel how they press on some single teeth somewhere. We have produced them completely contact-free using optoelectronic scans. This means that one tooth or the other must have moved a little since then. And when I take the splint out in the morning after wearing it at night, it takes a few minutes for the teeth to all fit together exactly and correctly again. Do you also know that kind of feeling? At this point in the lecture, I always share my interpretation of the fairy tale The Frog King or The Frog Prince, taken from my book Mein Gesicht. This book has not yet been translated into English, so I have to tell you the story. So, fairy tales always have a historical and socio-political background, if you like to see it that way. And I see the connection to our topic here, to the periodontium. When I consider the real oral health, periodontal health, is only really being realized in this time, in our generation. I think that today it is normal and customary for you to have a dental hygiene checkup every 6 months to keep your teeth and your periodontium healthy. Your oral cavity biotope is brought back into balance. That wasn't the case when I was a child. My parents and grandparents didn't know that either, and not even the dentists didn't know that, and they were helpless against the so-called periodontal disease back then. And even longer ago, when fairy tales were created in Europe and collected and written down by the brothers Grimm, oral health was a completely different matter, namely bad. You rarely see a portrait painting from that time in which the person depicted is laughing and showing their teeth. Even Mona Lisa by Leonardo da Vinci doesn't really laugh. There was probably a reason for that. And fairy tales always depict the desire for an ideal world. They are fairy tales, after all. So that's what it says in my book. There are many in-depth psychological interpretations that you can read about elsewhere. But I also think the following scenario could be very, very realistic. Did the princess really want to kiss the prince she was supposed to marry? So it is undisputed that in that time of princesses and princes, there were definitely forced marriages because the estates and the properties had to be enlarged through clever marriages. Then the princess and the prince would ride towards each other, she on a white horse, beautifully adorned in a white dress with a veil and flowers, and he on a black horse, also beautifully decorated with a hat and feather and a magnificent robe. The people formed an alley and paid homage. On the castle bridge, as I imagine it, the two horses met, the horses stood opposite each other, side by side, and now they were to kiss, still on horseback, in front of the proud parents, the relatives, and the court people. She lifted her veil. I think by now I know why the veil existed in the first place. And she smiled at him, and he got a huge fright. The dental findings I made up, but very realistic if you take the grave findings of the skull and on display in the museum as a basis. So, the left central incisor was broken off and a pea-sized lump was bulging out from under the gum at the tip of the tooth, from which pus sometimes leaked out. And the right second incisor had a blooming caries and was completely black, probably because the pulp had died, and the left second incisor was missing, and a black hole was yawning there. And the canine tooth next to it protruded pointedly into its gap. And what's more, the 17-year-old princess smelled harshly from her mouth as she smiled. The prince was no different. He had a nice beard on his upper lip, curved to the right and to the left, and his chin was plucked vertically, but that didn't really distract from his teeth. I'll save you the trouble to picturing that also. In any case, the princess probably thought that moment that it wouldn't be much worse to have to kiss a nasty frog. And secretly, she was probably imagining what a fully toothed, periodontally healthy mouth would taste like. After this short literary excursion, we return to structure biology. Now let's take another look at how the structures of the tooth supporting tissue are formed. The formation of periodontal structures is a highly complex process that I have described in detail in my textbook. At this point, I can only provide a summarized overview for you. The whole process takes place while the root is being formed. Hertwig's epithelial sheath is the duplication of the inner and the outer epithelium, and it determines the shape of the root to which the odontoblasts attach from the inside and deposit dentine. We have already seen this during the tooth development in the chapters on dentine and on root formation. So Hertwig's epithelial sheath then largely dissolves and allows the cementoblast to deposit cementum on the dentine surface. However, the cementoblast must come from somewhere. It is possible that the bare dentine is the trigger for some cells from the dental follicle, in which the tooth primordium is still located when the root is forming, to differentiate into precursor of cementoblasts. These then become cementoblasts. At the same time, some cells of the dental follicle are induced to develop into pre-fibroblasts, which then also become fibroblasts and form the fibers. This all takes place simultaneously, and so it is possible that the fibers, when they are formed, grow firmly into the cementum as soon as it is formed. And the alveolar process bone develops from the mesenchymal connective tissue that surrounds the dental primordium, and the retaining fibers also grow into it as it forms. The blood supply to the periodontium in the maxilla comes from branches of the posterior and anterior alveolar arteries, the infraorbital arteries, and the palatine arteries. And these ultimately originate from the maxillary artery. And in the mandible, the mandibular arteries, the sublingual arteries, and the mental and buccal arteries reach their respective periodontal tissue, which is closest to them. Innervation comes from the respective branches of the trigeminal nerve that also reach the teeth. And here again, in detail the blood supply schematically. The blood vessels of the periodontal space area are connected to the gingival plexus and also to the pulp via the many side channels through the root dentine. And of course, with the bone marrow spaces of the alveolar bone also. This means that these are also pathways for possible spreads of inflammation, which must of course be known by you. The area that surrounds the tooth like a collar with epithelial and connective tissue attachment is known as the biological width. It varies in size by the individual and also from tooth to tooth. However, the clinical average is assumed to be about 2 millimeters, made up of 1 millimeter epithelial attachment and 1 millimeter supracrestal connective tissue attachment. And when the gingival sulcus is explored by the dentist, a distance of 2 millimeters should be maintained between the deepest probing point and the bony alveolar crest. The biological width should remain intact, especially during restorative procedures. And if the position of the preparation margin for, let's say, for a crown preparation needs to be placed into the area of the biological width, a surgical crown lengthening is required in which the alveolar crest is reduced in height. Alternatively, an orthodontic crown lengthening, well, the crown cannot be lengthened. It is just that you extrude the tooth from the bony socket. This is an orthodontic extrusion, can also be carried out. Aesthetic concerns do play a role, in particular in the relation to the anterior teeth, of course. And the biological widths must be taken into account when placing dental implants. After all that, what we've discussed so far, it has probably become clear that the gums surrounding the tooth, the regions at which the crowns of the teeth enter the oral cavity, really must be kept very healthy. If there is an inflammation in the periodontium, this would mean a gateway for all kinds of pathogenic germs to enter the bloodstream, because, as we have seen, the periodontium is very well supplied with blood vessels. In a worst case scenario, even an endocarditis could even be associated with periodontitis. After all, the entire wound surface of the periodontium is as large as the palm of your hand. That is what you have to keep in mind. Damage to the periodontium can have a variety of causes. And take a look at the picture on the left. These are florid inflammations with hyperplasia of the tissue. And you can recognize the cause immediately. Terribly poor oral hygiene. But in the picture on the right, oral hygiene is super good. And yet there are recessions of the gingiva and thus also loss of tooth supporting tissue. Traumatic dental premature contacts can be one of the many causes, such as an edge-to-edge bite of the right central incisors here. But there are also idiopathic genetic causes. This is where periodontologists are called upon to give us answers and treat us if we are affected by any periodontopathy ourselves. Now the take-home message. We have now gained an initial overview of the structure of the retaining tissues that hold the teeth in their bony compartments. We have seen how the emergence of the dental crown is sealed by the gingiva in the oral cavity and how the individual structures are formed. This also provides clinically important information such as the preservation of the so-called biological widths or the pathway of inflammation. Periodontopathies can have a variety of causes which you can understand better if you know the structural biological basics. I am relying on you. Maybe one day I will be your patient. Who knows? And I thank you for your kind attention.